And we are off and racing again, aren't we? Trying to make people understand how stupid 299,792 kilometers per second is for the speed of light. It's an absurdity. It looks like there's a lot on the board, but there really isn't, right? I'm trying to make this as understandable as possible. Right. This is all about the speed of light. The sun taking 4.6 seconds to radiate light, distance of its diameter. From there to about there, 4.6 seconds. 1, 2, 3, 4.6 seconds. You know what I'm saying? It is an absurdity, okay? Now, I've done this before, but this is a different version, a different angle, okay? So a couple of things to start with. 8th of September, that will be the solar eclipse, I think. Right. Remember, these are facts, but only because of the numbers they give us, okay? The chances that any of this is right, 0, because the speed of light is wrong. So all the calculations that have 299,792,458 meters per second in it are also wrong. All of it out of whack. The whole shit shebang cadoodle. Is that right? Cadoodle? Right. We have 150 million kilometers in between the sun and planet Earth. 150 million kilometers. If we divide that 150 million kilometers by the sun's diameter, which is 1,390,000 kilometers, we have 108 sun diameters. So there are 108 suns in between Earth and the sun. Now this right here should kind of be enough. It's only 108 sun diameters away from us. It's 108 diameters of itself away from us. That's like me being 100 of me being away from a pint of beer. On your marks, get set, go. 8 minutes and 20 seconds. No, I don't think so. Right. 108 sun diameters. If we use a 1.1 centimeter bulb, light bulb, and we use that as the sun, right? We're keeping things to scale here. To find out the distance to Earth, all we do is multiply that 1.1 centimeters by 108. And that gives us 1.18 meters, 118 centimeters. All right? That is all we need on this side of the board. This right here is a 1 centimeter diameter light bulb. Okay? I'm going to turn it on in a minute. Real science, where you can physically see what is happening. Like, I'm not going to try and slow-mo film light crawling through a bottle, because that's impossible, because light is absolute. That was all Mickey Mouse. Fact. Slam dunk. Right. On the other side, we want Earth's diameter. If we've got a 1.1 centimeter diameter light bulb as the sun, we want to know what diameter Earth is, just for a point of reference, okay? So, if we divide the sun's diameter by Earth's diameter, 1,390,000 kilometers by 12,742, we get 109. So everybody knows that little gimmick, isn't it? Everybody likes to bring that up. Oh, there are 109 suns in 109 Earths in the sun. So we'd have 1, 2, 3, 4, 5, 6, 109 Earths. All right, that's how many Earths are in the sun's diameter. So, if we divide that sun's diameter, which in this scenario is 1.1 centimeters, we divide it by 109, we get 0.1009 millimeters. It's basically 100 micrometers, a tenth of a millimeter, just over the 10th of a millimeter, right? So if the sun is a 1.1 centimeter light bulb, planet Earth would have a diameter of just over a tenth of a millimeter, right? So tiny, 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 just over a tenth of a millimeter. Right, now, according to the speed of light, if we divide the sun's diameter by the speed of light, we get 4.6. I liked this stick. 4.6 seconds. It takes 4.6 seconds for the sun to radiate its own light the distance of its own diameter. This right here should be the end of it, right? It should be the end of it. Nothing takes 4.6 seconds to radiate anything its diameter, right? But light. The sun up in the sky, they're telling you, when you look up at the sky and you see that sun, during an eclipse, when the moon is directly in front of the sun, and there you go. The moon is, give or take, is the same diameter as the sun when the solar eclipse is taking place. Can you picture the moon taking 4.6 seconds to radiate its own light the distance of its own diameter? If the moon were the sun. Bang, right there. No, it's ridiculous. But the sun behind that moon, even though it's so far away and it has a diameter of 1,390,000 kilometers, behind the moon, that sun is radiating, allegedly, it's not, its light at a rate of 1 diameter every 4.6 seconds. It's the same diameter as the moon during the solar eclipse. So the sun behind that moon is going 1, 2, 3, 4.6 centimeters, 1 diameter, and then another. Guys, if you cannot see how stupid thinking anything takes 4.6 seconds to radiate its own light, the distance of its own diameter, this right here is the common sense line, right? Now, let's turn this light off. This right here, what I have, this just over a 1 centimeter diameter bulb, right? It is perfectly to scale. This is exactly the same as the sun having a diameter of 1,390,000 kilometers, and there being 150 million kilometers in between the sun and an Earth. There's a nail there, so we should just see a shadow, right? This is perfectly to scale. So what they are saying up there, this is not happening. I'm saying this is what happens. Bang. Sun turns on. Bang. Whoosh, whoosh. There's no 8 minutes and 20 seconds. There's no 4.6 seconds per diameter. But what you're being told is if this sun turned on, bang, it would take literally, you'd sit here for freaking 8 minutes and 20 seconds watching the light crawl along, because this is perfectly to scale, right? This is perfectly to scale. What you are being told is it would take 8 minutes and 20 seconds for this 1.1 centimetre light bulb to get its light over to that tenth of a millimetre Earth. Yeah, but what was the one that people used to keep throwing at me? That can't be perfectly to scale. Oh, it was something, I can't remember what it was. But it is perfectly to scale. And because it's perfectly to scale, the time is perfectly to scale as well. So the time is still going to be 8 minutes and 20 seconds. All I've done is reduce the size of the light source and planet Earth. The time remains the same, right? It's to scale. We're not changing the time, it's the time that we're trying to show how stupid it is. Now, to think that the sun radiates its light at a rate of one of its own diameters every 4.6 seconds. So this, like I said, it's the common sense line, right? It is. 1, 2, 3, 4.6. If this was the sun, that's what it would be doing, right? Now, what another ridiculous angle on this is what they're saying is as something gets bigger and more powerful, it radiates its light slower in relation to a smaller version of its previous self. This light bulb, you can see this light bulb, there's somebody 5Ks away, they will see this instantly, bang, 5Ks. 5 centimetre diameter, that's 100,000 diameters. It's 5 kilometres from here. That is 100,000 diameters, and I guarantee that on a dark night, this is probably 10 kilometres, 6, 7 miles. We're going to stick to 5Ks. That is 100,000 of its diameters in an instant. Boom! Now, the sun will do exactly the same as that. 100,000 times its 1,390,000 kilometre diameter. What is that one? I'll have to ask Alexa because I hadn't thought about this one. Alexa, what's 100,000 times 1,390,000?
100,000 times 1,390,000 is 139 billion.
139 billion. 139 million. 139 billion kilometers. Yeah. The sun turned on from off like this. And this can be seen at 5Ks. That is the equivalent of the sun turning on and being visible at the very same time, but 139 billion kilometers away. That is how fast. It's absolute light. And if this can be seen further away, the sun, it will reach there at the same time. There is no delay. You would not be able to measure a delay in light from someone on the moon, on Pluto, 100 billion kilometers away, and then at the limit, 139 billion kilometers away. If the sun turned on from off, you had people in all those different places, they would all see that light, bang, at the same time with no delay. The bigger and more powerful the light source, the further it will radiate its light. Not faster, further at absolute speed. And just one more, add one more thing to this. The sun takes 4.6 seconds, right, to radiate its own light the distance of its own diameter. It's so freaking stupid, right? And when I say the bigger a light source gets, the slower it radiates its light in relation to a smaller version of itself. UY Scooty. UY Scooty, one of the monsters of the heavens, so they say, right, with a diameter of 2.3 billion kilometers, right? Look, I can't find any orange. Oh, yes, I can. The diameter of 2.37 billion. 2.37 billion kilometers, right? It takes UY Scooty 2 hours and 12 minutes to radiate its own light the distance of its own diameter. 2 hours and 12 fucking minutes. Guys, honest to God, did you? Sorry, I don't mean to blaspheme and all that. Right. Like, that's not an absurdity either. If we divide UY Scooty's diameter by the speed of light, I cannot remember what it is. This is going to be fun. Don't not lie to me, Alexa. Alexa, what's 2,370? Stop! Alexa, what's 2,370,000,000 divided by 299,792?
2,370,000,000 divided by 299,792 is approximately 7,905.4811.
7,904. I thought it was 7,908. I think that should be 2.377. So 2,377,000,000. So I'm pretty sure that's an 8. Alexa, what's 2,377,000,000 divided by 299,792?
2,377,000,000 divided by 299,792 is approximately 7,928.8307.
28. That's right. Right, look. This is spontaneous 7,928. Right? 7,928. If we divide our sun's diameter, 1,390,000 by 299,792, we get 4.6. That's seconds. If we divide UY Scooty's diameter by the speed of light, we get 7,928 seconds. Alexa, what's 7,928 divided by 60?
7,928 divided by 60 is approximately 132.1333.
132. And that is minutes. 120 minutes. That's 2 hours with 12 left over. 120, 132 minus 120, and 12 minutes. So, The sun, this bulb goes bang, 100,000 diameters in a heartbeat, right? The sun takes 4.6 seconds to radiate just one diameter. And you, by Scooty, with a diameter of 2.377 billion kilometers, way more powerful than the sun. I think it's a little bit more powerful, that light bulb, but it takes 2 hours and 12 minutes to radiate its own light, the distance of its own diameter. And that is because of that stupid Mickey Mouse speed of light that there is no evidence for anywhere. There you go. If you think there is any scenario where anything, it doesn't matter how big or small the light source is, any scenario where a light source would take 4.6 seconds to radiate its own light, the distance of its own diameter, it's ridiculous. It is ridiculous. A light source will radiate its light at absolute speed as far as it's going to reach. The bigger and more powerful the light source, the further that light will radiate, not faster. Bang! That is a fact. I guarantee you the speed of light is wrong. And during a solar eclipse, the only way it can play out with the sun directly behind the moon is with absolute light. Because otherwise, if it was finite light, planet Earth would have rotated 2.08 degrees anti-clockwise on its axis in the 8 minutes and 20 seconds that it took the photons to arrive. You cannot see the light source at the same time as the Mickey Mouse photons that have been traveling for 8 minutes and 20 seconds at the same time. Where is the delay? Where is the delay? There is no delay. It's absolute light. Buenas noches. Later, peeps. I will be back with more.